Imagine if we could see Wi-Fi. What if the world around us shimmered with vibrant colors, pulsing patterns, and swirling waves of light? What if these weren't special effects from a science fiction movie, but the very air we breathe, suddenly visible? This is the intriguing possibility if we could see Wi-Fi signals. Imagine walking down the street and seeing a kaleidoscope of colors emanating from homes, cafes, and offices. Each signal would be a unique signature, a vibrant beacon in the electromagnetic spectrum. Imagine the night sky, not just twinkling with stars, but alive with the glow of interconnected networks spanning the globe. This ability to see Wi-Fi would be more than just a visual spectacle. It would be a window into a hidden world, a realm of data and information constantly flowing around us. Like a sixth sense, it would transform our perception of the environment and our relationship with technology. But what exactly are these invisible waves we call Wi-Fi? To understand their potential appearance, we need to delve into the fascinating world of electromagnetic radiation. We often perceive the world through our five senses: sight, smell, taste, touch, and hearing. But beyond our limited perception lies a vast spectrum of energy invisible to the naked eye, the electromagnetic spectrum. This spectrum encompasses a wide range of waves, from radio waves with wavelengths the size of buildings to gamma rays smaller than an atom. These waves, including Wi-Fi, are created by the movement of electrically charged particles. They travel at the speed of light, but their energy and how they interact with matter depend on their wavelength. Visible light, the tiny portion of the spectrum our eyes can detect, allows us to see the world in a riot of colors. Wi-Fi, on the other hand, occupies a different part of the spectrum, the radio wave region. These waves have much longer wavelengths than visible light, which is why we can't see them. But just because we can't see them doesn't mean they're not there. Like a bustling city hidden in fog, Wi-Fi signals are constantly buzzing around us, carrying data and connecting devices. So if we could somehow shift our vision to perceive these longer wavelengths, what might Wi-Fi look like? If we could see Wi-Fi, our world would be transformed into a dazzling light show. But unlike the static colors of painted walls, Wi-Fi signals would be dynamic, morphing and shifting based on their strength, frequency, and the amount of data being transmitted. Imagine a coffee shop, a hub of connectivity. The room would pulsate with a warm, inviting glow as devices connect to the Wi-Fi network. Strong signals would likely appear as vibrant solid beams of light, while weaker signals might flicker or fade in and out like fireflies. The colors themselves could correspond to the frequency of the signal. Just as different wavelengths of visible light create different colors in a rainbow, different Wi-Fi frequencies could manifest as distinct hues. We might see bands of red, blue, or green, each representing a different channel of the Wi-Fi network. As data flows through these invisible channels, the patterns would change, reflecting the ebb and flow of information. A simple web search might create a ripple of light, while streaming a high-definition movie could unleash a torrent of color and movement. In a world where Wi-Fi is visible, finding a strong internet connection would be as easy as looking for the brightest light. No more struggling with weak signals or endlessly searching for the best spot to place your router. Imagine walking down the street and instantly knowing which businesses offer free Wi-Fi and which ones don't. Public spaces would be transformed, with parks, libraries, and even public transportation glowing with the promise of connectivity. This newfound visibility could also have practical applications. Technicians could easily identify areas of interference or signal weakness, optimizing networks for better performance. Security professionals could visualize potential vulnerabilities, identifying rogue access points or unauthorized connections. However, this constant visibility could also lead to information overload. Imagine trying to focus on a conversation in a crowded room filled with pulsating lights, or trying to enjoy a quiet evening at home surrounded by a constant hum of data. Our brains would need to adapt to filter out the noise and focus on the signals that matter most.